Okay, now next example is we want to construct a Turing machine which find first complement of a binary number. So some binary number is given to you, say 10101, and we know that the first complement of this number is we have to alter, like this 1 is replaced with 0, 1, 0, 1 and 0. So this is input and this is output that we want to display onto the tape, right? Okay, now again here this example is related to Turing machine which works as a transducer, right? And on tape we have say 1 0 1 0 1 and here some blanks are there. Read write head is here. Now what we need to do, we are in some state Q0, and what we need to do, if some 1 is there we want to replace it with 0, if 0 is there we want to replace it with 1. So if there is 1, replace it with 0, move right. So if there is 1, then replace it with 0, and so actually this 1 is replaced with 0, but for simplicity here I am trying to write another tape. So this 1 is replaced with 0 and we move right. When we move right, if 0 is there, replace it with 1, move right. So this 0 is replaced with 1, this 0 is replaced with 1 and move right. If there is 1, replace it with 0, move right. 0, replace it with 1, move right. 1, replace it with 0 and we are here. When we are here, when there is blank, keep it as it is, move left, right? When we move left, we are here. And generally what happened, good practice to design Turing machine is, again we have to jump where initially our read write head was there. So what we need to do, once blank is replaced with blank, move left. So what we need to do, we need to traverse left side until we find blank. When we find blank, move right. So read write head is here. So what we need to do, because here all ones are converted into zeros, zeros are converted into 1, so already number is in first normal form. So once we reach to blank, keep it as it is, move left. When we move left, whatever zeros we have, keep it as it is and move left. Whatever ones we have, keep it as it is, move left. When we move left, if there is blank, keep it as it is and move right. This is Q0, this is Q1, this is Q2. So once all this transition says that all ones are converted into 0, all zeros are converted into 1. When we reach to blank, keep it as it is, move left. Once we move left, what we need to do, we need to traverse all the symbols, keep those symbols as it is until we reach to blank. So all zeros can be as it is, all ones can be as it is. Once we reach to blank, keep it as it is and move right. Right? So initially when our input was written onto the tape, read write head is here. When we write the logic, when we convert all ones into zeros and zeros into 1, so this is what the output is generated and read write head is here. So this is one example. Now next example is, let's convert Turing machine, let's construct Turing machine which finds 2's complement of a binary number. So during Murray and Mealy construction, we discussed that 2's complement is what? Suppose if 10101 we have, this is our number, and in order to find the 2's complement, and suppose say 00, in order to find the 2's complement, what we are doing is we try to read from LSB to MSB, and we know that whatever zeros we have, keep it as it is. Whatever zeros we have, keep it as it is. When there is one, when there is first one, keep it as it is. After first one, all the symbols are altered. 0 is converted into 1, 1 is converted into 0, 0 is converted into 1, and 1 is converted into 0. So this is your binary number and this is your 2's complement. And we have already cross-checked that this logic is correct. Suppose if we have 1 0 0 1 0 1 0. So we have to read the input from LSB. Whatever 0 we have, keep it as it is. When there is first one, keep it as it is. All the symbols are altered. 0 1 1 0 1 1 and 0. Right? If we cross check, then we know that the traditional method that we are following in order to find 2's complement is, this is our number. First we find the first complement. So here we have 0 1 1 0 1 0 1 and we add 1. So we have 0 1 1 0 1 1 0. So this number is same as this number, right? So we follow this logic in order to construct the Turing machine. So suppose some number is given to you. Say we take same number 1 0 0 1 0 1 0 and blank. So initially read write head is here. Now what is the first thing that we have to do? We have to traverse all this number until we reach to the MSB, right? Because here this logic says that we scan all the numbers. When we find the LSB, if there is 0, keep it as it is. If there is first one, keep it as it is. And whatever remaining numbers we have to alter it, right? So here what we need to do, we are in some state Q0. So what we have to do, if any zeros we have, keep it as it is, move right. Whatever ones we have, keep it as it is and move right, right? So here we need to traverse all the symbol. When there is blank, keep it as it is, move left. So we are here. When we move left, whatever zeros we have to keep it as it is. So whatever zeros we have, keep it as it is, move left, right? But when there is first one, this 0 is as it is, right? This 0 is as it is. Now when there is first one, keep it as it is, move left. So when there is first one, keep it as it is. But after first one, whatever symbols we have to alter it. So meaning is, whatever zeros we have to alter it with 1, move left. Whatever ones we have to alter it with 0, move left. So after we read first one, 0 is converted into 1, 1 is converted into 0, 0 is converted into 1, 0 is converted into 1, 1 is converted into 0, and when we reach to blank, keep it as it is, move right. So your read right head is here. This is Q0, Q1, Q2 and Q3. So if you observe, this is our input, right? And after the logic, what happened? We have 0, 1, 1, 0, 1, 1 and 0, right? So in order to convert any binary number into 2's complement, whatever binary number you have, just we have to traverse all the digits until we reach to LSB. And rule says that whatever zeros we have, keep it as it is. When there is first one, keep it as it is. After first one, all the previous symbols is altered. This is how we can convert any Turing machine. We can construct Turing machine which finds the 2's complement. Again, these two examples are related to Turing machine which works as a transducer. Okay, thank you.